Hello everybody, and in today's video we're going to be talking about Apache Spark. More specifically, we're going to talk on a high level about what Spark is and why you'd want to use it if you're a data analyst, a data scientist, or you're simply just trying to gain better understanding and working knowledge of this kind of technology because it's a space or a field you see yourself getting into in the future. Then I'm going to give a step-by-step guide on how we can actually simulate what using Spark in a business context would look like. And we're going to do this by connecting our AWS free tier account that you see on the left with our Databricks standard free trial account that you see on the right. Both of the links on how we can sign up for the AWS free tier account and the standard free trial Databricks account will be found in the description of this video. So please use this moment to pause the video and sign up if you haven't already done so, as you will need it to follow along in this tutorial. And finally, we're going to use the rest of the video where I can show you how to read data and perform some general Spark functions so you can be on your way to making amazing Spark programs. So why use Spark? And before understanding the answer to this question, let's first talk about what big data is. On its face, if you knew nothing about what this field was and somebody asked you, what is big data? I feel like you would be able to deduce that it's probably referring to large amounts of data. And while this is true, it doesn't give you the full scope of what it means. And in addition, it does not address the implications it may have on an individual performing some type of analysis on this data. So to address the former and what big data means, big data refers to a large and vast variety or scope of data points that is being gathered and collected at extremely fast rates. And I guess this definition can lead itself to the founding principles or foundations of big data, which comes from volume, velocity, and variety. So with this as a base level understanding of what this concept is, what does it mean for an individual working with this kind of data? So when performing some general data analysis or machine learning techniques on a simple data set, you can often use your local desktop to perform all these analysis or even implement a machine learning model. But what happens when the data is very large? When I say large, I don't mean a few megabytes. I mean it could go stretch on to terabytes in size. This is where it is impractical and in most cases insufficient to use your local desktop to do such analysis. And this is because of the limitations you might have on your hardware components, such as your memory or disk drives. And even if you did have those things, it might be in the form of speed. It might not be working as fast as you want it to. So, what then is the solution? And this is where you introduce a big data process where these limitations that we talked about speed and hardware components, are circumvented. But and since most organizations have a big data process in which this is addressed, I will be speaking mainly about one of the more popular frameworks, Apache Spark. And the reason why we're talking about this technology specifically is because of the impetus it has in its growth in a multitude of different industries and the benefits that is being really evident on analytical professionals. So Apache Spark is an open source analytics engine for large scale data processing. It is an extremely powerful tool, and it can be used for managing, working with, and performing analysis on machine learning on large data sets. And moreover, it supports the programming languages used for analytics and data analysis that you might already use right now. It has API support for Python, R, and Java. And just a simple side note, Spark is written on top of Scala. So that's just something that I thought was interesting when I was learning about this technology. Now that we have a foundational understanding of what big data is and what Spark is, now it's time to connect our Databricks account with our AWS account. And just a disclaimer, I am not affiliated or promoted by these two companies. It just so happens that these are the two platforms I use to work on my Spark skills as well as gain a better understanding on how to use Spark and how it applies in a business context. Now, why are we using Databricks specifically? So In addition to the founders actually being the inventors of Spark, it provides an easy UI that can be utilized to avoid the very, very daunting task of the manual setup required to actually use it. The most difficult part you'll often see with this technology is not so much using it, but it can oftentimes be the process to get you to a point where you can actually write and execute Spark scripts. Databricks reduces these barriers significantly. And in the cases of this video, all we need to do is connect our Databricks with our cloud provider. In this case, it's AWS, but it can very well be Microsoft Azure or GCP, and it allows Databricks to deploy instances or resources it needs for Spark to run. And it also should be mentioned that there is a service within AWS that you can provision clusters where Spark is actually already installed and configured. And this is the EMR service. It's called ElasticMapeReduce. Just based off of my experience, I ran into a lot of issues while using EMR. And this is why I opted in to use Databricks instead of AWS. So just know that AWS also offers Spark usage through this EMR service. So let's just first familiarize ourselves with the UI. On the AWS side, when you first log in, you'll see this AWS Management Console. You can think of it as a dashboard or a home page, and it's a way for you to create and manage your AWS resources, which we will need to set up to facilitate the connection to Databricks. Another thing to note is on the right, if you click on it, you might have a different region selected, but what this refers to is a physical location where the data centers are located. Well, AWS's data centers are located. These data centers are found in these things called availability zones. And usually there are at least two availability zones within each region. And we're going to see later why setting this to the appropriate region is important. And this is what allows AWS to give its customers its highly scalable, highly available, fault tolerant services. And just note that this region should be set to the region that is physically closest to you. Just because this is was going to give you better latency and performance. On the Databricks side, when you first log in, you'll encounter a UI that looks something like this. We're particularly interested in the cloud resources portion, and this is because we're going to need to give Databricks the appropriate credential configuration as well as storage configuration so we can launch something called a workspace. A workspace is an environment that is used to manage and access your Databricks assets. And this is where it uses the credential configuration alongside the storage configuration to facilitate the connection to our AWS account such that it can deploy the resources it needs for the SparkSession to operate and work. We begin by adding our credential configuration. Now we can do this by hovering over to Cloud Resources on Databricks and then going over to Add Credential Configuration. So when you do this, there's a tab that's going to pop up, and there's two main things that we're going to have to take away from this tab. One of them is that we need to create a cross-account IAM role in our AWS account. A cross-account IAM role is used to define access to resources in a single account, that single account being ours. And the next thing we're going to have to do is click on this link, this hyperlink over here is going to take you to a separate documentation that you're going to have to follow along for the purposes of copying and pasting certain codes and account numbers that you're going to have to copy and paste to your AWS account when we're creating the role. Next thing we're going to do is just give you a better understanding of external ID. External ID is a particular unique ID that is specific to your account. We're going to also need this when we're creating our IAM role, so please have this ready or handy with you when we get to that step. Now it's time to head over to our AWS account, and from here we need to access Identity Access Management, or IAM. If it's found in your recently visited services, you can access it by just clicking here, or you can search for the service in the search bar right on top. Now, Identity Access Management is a way to grant certain users policies or permissions to do certain things in your AWS account. It's a way for you to decide who does what in your account. Without permission being explicitly granted to an IAM user, the user will not be able to access any AWS services. So generally, a company's IT department will be responsible for quote unquote attaching what are called IAM permission policies to an IAM user. And this is based on what the user needs to access to in order to do their job. So this is just a high level understanding of what IAM is. So we can now head over to IAM. When you finally get into IAM, we need to hover over to roles, create a role, and add another AWS account. And if you're following along with the cross-account IAM role, then please just put in the account ID for Databricks. So what we're doing here is that we are giving, or we are telling AWS that Databricks is a trusted entity, and after we set the permissions that it can do, it can deploy a lot of different instances or provision clusters for Spark to run in their platform. So this is why we are doing this right now. Then we need to require external ID, and remember the external ID is the unique sequence to your particular account, your Databricks account. So we need to go back to our Databricks, grab and fetch that external ID, and we need to input it here. So after we input it here, we can then click next. We don't need any tags. We can just review, add a role name. We can just write Databricks AWS role demo 2. We can create the role, and now we can search the role that we created. After creating the cross-account IAM role for Databricks, we need to give it permissions so Databricks can utilize and provision certain resources within our AWS account so that we can use Spark. How we do this is by adding an inline policy, hovering over to JSON. Now, as you should be following along in the cross-account IAM role, there's going to be a JSON policy that you will need to copy and paste here. But it is very important that you select the Databricks VPC. The reason why this is easier is because we're going to be connecting through Databricks' virtual private cloud, which leads to a lot less configuration as compared to connecting to your own VPC or facilitating the connection through your own VPC, which requires a little bit more work and more effort. So for our cases, we're going to be using the Databricks' VPC. We're going to be taking the code and copying and pasting it here. We're going to be reviewing the policy. We're going to give the policy a name. We're going to say Databricks AWS policy demo. And we're going to create the policy here. Now, once you've created it, you're going to see at the very top, there's something called the role ARN. ARN stands for Amazon's resource name, and what it does is it uniquely identifies AWS resources. This ARN is unique, and it is unique across not only to your particular AWS account, it's unique across all AWS. And it allows Databricks to uniquely identify the role that was created and given to it. And not only that, but it is also able to reference the policy from that particular ARN such that it can facilitate the connection to our AWS account. So what we're going to need to do here is we're going to need to copy this and paste it to this particular field in this tab here. And we're going to have to assign it a name. We're just going to write configuration credentials DB AWS. So once you have the name and the role ARN, showed you how we can get this done from AWS, we can just click add. And now this has been successfully added to your credential configuration. Now that we've created our credential configuration, it's time to move forward with creating our storage configuration. Now, the reason why we do this is because we need Databricks to be able to use our S3 service so that it will be able to save things like our notebooks, our task logs, and other Databricks resources. So S3 actually stands for Simple Storage Service, if you're not familiar with it already, and it is AWS's storage service. A few key terms that we're just going to have to go over is what a bucket means and what an object means. A bucket is a root level folder you can create in S3, and buckets take the highest level of a particular folder. Within a bucket, you can create things called subfolders, which is referred to as an S3 subfolder. What you store in an S3 bucket is what you call an object. An object can take any format such as Parquet, OSV, XLSX, CSV, JSON, etc. An interesting note is that almost every service you'll find within AWS will integrate with S3 in some way. So now with this high-level understanding, let's just go ahead and add storage configuration. One thing to note is we're going to have to create a bucket in our S3 service. And the reason why this is the case is because we have to assign and give permission to Databricks to be able to access that S3 service within our AWS account. So let's begin by creating a storage configuration name. This can be any name that you want. So I'll just write storage Databricks AWS. And the bucket name, I'll just label it as storage DB AWS demo. So just note that we're going to have to use this exact bucket name when we're creating the bucket in our S3 service in AWS. So if we go over to AWS and in the top bar search for S3, this will give you all of the buckets available within your AWS account. All we have to do now is create a bucket, give it the name that we just assigned in our Databricks account, and you have to set the region to the exact region that is closest to you, one. And secondly, the reason why this is important is we're going to have to match this particular region with the region that we're going to be choosing in our workspace. This is important. If you do not select the same region, it will not work. You will get an error when deploying a workspace. So just make sure that these two things are aligned. Next thing, you can leave everything in default. With the bucket versioning, it is recommended that you enable it just in case you need to go to a previous version in your bucket, but for our cases, we're just going to disable it for now. We don't need any encryption just because this is for demonstration purposes. And now we can create the bucket. So when you create the bucket, we should be getting a successful alert up top. And you can see that it is available down below the bucket that you have created. So we can access this bucket, head on over to permissions and go to policy, click edit. And if you go back to your Databricks console, you'll see that in the bottom, it says generate policy. What this policy will generate is the required permissions we need to place into our S3 bucket for Databricks to be able to save whatever it needs to save there. So when you click on it, and in the bottom of the JSON file, you'll see it's referring to the exact bucket name we will be creating in S3 in our AWS account. Then we copy over the generated JSON policy over to our S3 bucket policy and click Save Changes. So now we have given Databricks permissions to write and save things within this bucket. So we can now exit out of our AWS account. We have done everything that we needed to do to facilitate the connection, but I'm just going to save it on for now just to show you after we deploy our workspace and setting up our clusters, how this is going to be reflected within your AWS account. In our Databricks console, we can just click Add because all of these things have been achieved. And now we have created both our storage configuration as well as our credential configuration. So now we can create our workspace, and as we mentioned, a workspace in Databricks is where you can access all of your Databricks assets. So let's go on and get started with creating a workspace. So you can hover over to Workspace in your Databricks console, head over to Create, give it a name. I'm going to write testing demo. The region should match the region that you have selected in your AWS account, as we mentioned and discussed earlier. And the credential configuration as well as the storage configurations are the very things that we've just created. So for me, it's here and this one. And now we can click Save. So now what this is going to do is going to start provisioning and setting up our workspace. It shouldn't take more than a few minutes, and I'll be back when this is finished. So as you can see, our workspace is now running. So we can click on the workspace we created, hover over to the URL, and now we have our AWS Databricks setup configured and ready to go. Now, just a few things that we're going to have to familiarize ourselves with before getting into starting and provisioning clusters, which we're going to be doing in this tab, is we're going to have to understand first what a cluster is. So clusters are the physical computing resources that we're deploying from our AWS account to perform the Spark code tasks that we will be writing. And this is what we're going to have to manually provision over here. But with the help of Databricks, fortunately for us, this will not take much time. Another thing that we're going to have to understand is what a DBFS is. What Spark is actually built on top of is something called HDFS, which stands for Hadoop Distributed File System, or HDFS. DBFS acts as an HDFS in our AWS Databricks provision clusters. And the benefit of having this is that we can seamlessly access our data without requiring credentials, and we will not lose data even after the cluster is terminated because it seamlessly persists our data into our S3 bucket that we created in our AWS account. So that's what you got to know for DBFS. In addition to that, let's talk about what a master node is and what a worker or an executor node is. So Spark uses a master executor architecture. So let's just break these two things apart. So a master node is what typically contains something called our Spark driver. The Spark driver is what converts our program and schedules tasks to the executor, or oftentimes called the worker nodes. And a Spark executor or a worker node runs the task that made up the application that was sent to it by our driver program and returns that result to the driver. It also should be worth noting that these executors also store data for our application. So it is the facilitation of how these two things connect and work with each other through something called a cluster manager like Yarn or Apache Mesos that is what gives Spark its super fast speeds. So now let's begin by creating our cluster. So we can go hovering over here, clicking clusters, create a cluster, give the cluster a name. I'm just going to name it testing cluster. And then you see that in the cluster mode, it's selected as standard. So let's just go over what all these different options mean. So a standard cluster mode is usually used when you're in a development environment. So let's say you're performing some data analysis like we're going to be doing, or performing some individual jobs. Using standard clusters are the best. So there's another one called high concurrency, and high concurrency mode is a mode that's optimized for cases when you may have multiple users running jobs at the same time. And a single node cluster is a cluster that only consists of a Spark driver and no Spark workers. So it kind of does everything all at once. But for the purposes of this video, we're only going to be using standard, so we can click that. Over here, we can click on the latest version of Databricks runtime, so we can just write 8.2. And then you have something that's really cool here, says which is the autopilot options. You can see something here called enable autoscaling. So what autoscaling is the ability for, I guess, Databricks to scale up or down the clusters that are being provisioned based off of its needs. This is a very cost-effective way to manage your clusters. For our purposes, we're not really going to need our clusters to scale, so we can turn that off. And just so you don't get any unnecessary billing, we can put the terminate after 15 minutes of inactivity for our cluster. So if we're not touching or doing anything with our clusters within 15 minutes, it will terminate. Now, this is where we get to the worker type and the driver type, as we mentioned earlier what those two things mean. We're going to go ahead and search for M for large. It's a little bit more cost effective. And the driver type will be the same as the worker. So all we got to do now is reduce the number of workers because we really don't need that much. All we need is one. It'll probably do. And what we can do then is just press create a cluster. So this is going to take some time as it will be provisioning all the things that we've laid out in our AWS account and deploying it there. When this is finished, I'm going to show you how this will translate over to our AWS account. So now that we have our cluster running, and this can be evident by the green bubble over here, what we can do now is I'll show you how this is reflected in our AWS account. So all these clusters are actually being provisioned through the service called EC2, which stands for Elastic Cloud Compute in our AWS service. So if we go over here, search EC2, you're going to see that there's two instances running. So if you click on these two instances running, you'll see that these are the two exact instances that we provisioned in our testing cluster in Databricks. So this was just a pretty cool, interesting way that we can see how whatever we do in Databricks is reflected over to our AWS account. And this is why I wanted to keep this open, just so I can show you how that looks like. So we showed how when we provisioned our cluster, it is reflected in our AWS account. So now we can primarily focus on the Databricks console as all the work will be done here. One thing to mention is if you go on to clusters, it'll show you all the provision clusters you have and all the ones that are currently running. It is recommended that when you're done with your work that you terminate the cluster so you don't incur additional charges. It takes a few minutes to start or provision the cluster to get it to run, and it takes a few minutes to terminate. It really depends on how large your cluster is and how many nodes are comprised of it and what kind of nodes you set up. So this is just something to note. So now that we set up our cluster, we now need to head on over to the home, and we need to create a table. The reason why we need to create a table is because we need to have some data to work with using Spark. And we can do this through different ways. We can do it through here, or we can go through data, create a table. And there's a few data sources that you can actually get imported to our Databricks console. For our cases, we're going to drag files to upload. So this is going to drag it from my local desktop. And I'll be back with you when I've uploaded this file. Now, the data I'll be working with is from a telecommunication company that wants to figure out how to predict its customers' behavior so that it can retain its customers. A few things to know here is that when we upload the file, we're going to be uploading it to our DBFS target directory, DBFS standing for Databricks File System, as we discussed before. And what this is going to allow us to do is going to be allow us to use Spark code or SQL code actually to fetch the data and then perform some Spark functions on it. So it's a pretty cool way to fetch data, and this is why we're uploading it there. And we have two options here. We can create a table with the UI, create a table in the notebook. For simplicity, we'll just create a table with the UI. We're going to select the cluster that we created. We're going to click preview table. So we can just name the table as testing table. The database is going to be by default. As you can see, it's a CSV file, so it's going to be comma separated. The first row does contain the header. And we're not going to click infer schema. Infer schema will just infer what type of data that you have within each column. We're going to see how that plays out or how we can change it later on while we're writing code in our notebooks. For the time being, we can just click create table. So this is going to create the table in our testing cluster. So this is when we go to data here in our default database, we can see the table right here. So now we have our table that we want to work with. What we can do now is we can create a notebook. So we can go to notebook over here. We can go to the home page, click on new notebook, assign a name to it. I'll just assign it testing notebook. You can select the default programming language. It could be Python, Scala, SQL, or R. We're going to use PySpark, so we can use Python. And then we can create the notebook. So if you've ever used Jupyter Notebooks, you'll see that the Databricks Notebooks is quite similar. We have these things called cells here, and this is where you write and execute your code. You can change your theme. I have it set as a dark theme. You can very well keep it as the light. You can see the shortcuts in your keyboard for you to write or be more efficient when you're writing code. But everything that we have done up until this point is to get us to this step here. And this is where we can actually write Spark code and learn how to work with Spark. And setting up the clusters and connecting our AWS to Databricks, this is what's allowing us to work with this code, is because it's connecting to our testing cluster that you see here. And from here we can restart the cluster, and we can detach the cluster. Let's say you don't want this notebooks to use this cluster anymore. We can detach it from the cluster. So this is how you know this is the cluster that we're working with within our notebooks. So with that said, let's get on started with writing some code. And the first thing that we do is we need to import PySpark, because we'll be working with PySpark for the remaining of the video. And after this is where we have to initiate something called a SparkSession. So a SparkSession is the entry point to all of the Spark functionality. It is one of the very first objects you create when you're developing a Spark application. Once you create this SparkSession, it allows us to create a data frame based off of something called RDD, which is a resilient distributed data set, which is, I think you can think of it as a specific unique data set that is unique to Spark. And it's how it does these conversions. It is what makes Spark really efficient to use when working with large-scale data sets. In addition to that, what it allows us to do is it provides us the ability to write SQL queries using Hive QL, all while not having Hive already set up in our computer. So one thing that's really cool is when we first deploy a notebook, we'll see that SparkSession is already initiated, and it's usually configured or put into this variable called Spark. So if you just write Spark here, you'll see that we do have a SparkSession available, and it has a Spark context. So this is something that's really cool that we don't really have to worry about right when we launch a notebook instance. This is already installed for us or initiated for us. Now, for those of you who might be interested in actually building your own SparkSession and not using, the Databricks' own SparkSession, but I'm not really sure why, but only if you're not actually using Databricks, what you can do is you can overwrite the SparkSession that we have up top here, and we can pass SparkSession builder app name. Let's give it a name such as get started, and we can write get or create. So over here, you're going to see that SparkSession is not defined, so we're just going to have to import the SparkSession function. So we can write import SparkSession, run this again, and now if you pass Spark again, you'll see that it overwrites the existing Spark session that we already have configured up top, or that was already configured up top. So now I'll be introducing to you some Spark functions that might be useful to you, and things that you should just know about Spark going forward while you're performing some data analysis, as it'll be really prudent for you to have this general foundational understanding. So one of those things is how we can actually work with the data that we uploaded to our DBFS store, and how that is made possible by Spark. So what we can do is we can do something called passing an SQL function to our SQL context object. So what we can do is we can write df SQL context SQL select everything from, and if you're not sure what the table you've created name is, you can go to data, tables, testing table. So we know it's called a testing table. And this will store this table into the object df. So we can write df show. Show is, if you ever worked with pandas, is the equivalent to head. So you can write the number of rows you want to specify. In this case, it's 5. So df show 5 will show you the first 5 rows of the data set we imported from the data we uploaded to our DBFS store. So this is something that's really cool. Next thing, what you would want to do is probably see what the schema looks like of the table, and we can do this by passing print schema to our df I think I just wrote it wrong. Yeah, there you go. And what we're seeing here is, okay, it tells us if there was any missing fields, and what you really want to see is there any inconsistencies with the schema towards what the data set that we have is. So from the jump, we see that the monthly charges as well as the total charges are classified as strings, even though they are actually integers, so or numeric values. So let's say we want to convert them to integers. How would we go on about doing something like that? This is where we can pass something called with column to our data frame to make us work with a specific column and change it accordingly to the type that we want. So to do this, we can write df pass with the column total charges in our data frame. The column total charges has to be converted by using the cast function using the integer type. Now I'm pretty sure I haven't actually defined what the integer type or the call functions are, so the integer type or the call function, so we're gonna have to do that here. So we can write from PySpark SQL functions import call from PySpark SQL types import integer type. Oh, integer. Forgot to spell integer there for a second. And now if you go underneath, run this, we'll see that, okay, we didn't get any errors. That's great. Let's just do this for also the monthly charges. And then we'll examine if the appropriate changes were made. And we can do this by printing the schema again. And now you see that the monthly charges as well as the total charges are now classified as integers. Now, just for your knowledge, there's also other types that you might of PySpark SQL types that you might be cognizant of. Maybe you want to change it to a string type or a structured field or a structured type. What else? Or a Boolean type, or an array type, or a time stamp type. These are all types that are supported by the PySpark SQL types that you can import from here. So I just wanted to name them out just in case you have other data you're working with that you're trying to do this conversion between. All right, awesome. So let's continue on with our work. So now let's say we are trying to select a particular column within the data set that we are working with. And this is where we can pass something called select to our data frame. And what this is going to do is going to allow us to select a particular field within our data frame that we can possibly work with or examine a little bit further. So what we can do here is we can write df select, let's say total charges, and we can show the first 5 rows. So this will select the first 5 rows of total charges. So that's very interesting there. So this is how you can work with select. So what about the case where you might want to rename a particular column, or actually what if you want to modify a particular column? Let's say you're trying to multiply it by like 4 or 5 or whatever the case is. Now let's go with the case that you probably want to rename the column. So what you can do is pass something called with column renamed. What we can do is total charges and then change it to the name that we want. We can write TC. We can then select that column that we just modified, and we can write show the first 5 rows. See, so now what we did is with the column renamed, we changed it to TC, and we nested that with our select function over here to show the first 5 rows. So that's how you can use them both in conjunction with each other. Now, let's say we want to modify the same column, which is total charges, but we also just want to include the customer ID alongside the total charges modification that we did. And this is where we can use select, and we can do something like df select, df customer ID, and we can write df customer total charges times 6, and we can write show. And this is showing us the calculated field over here alongside the customer ID. Just write 5 just so it's a little bit cleaner. And this is a really cool way we can actually pick out a specific column and then just do a modification on another column. So that's a really cool illustration here. So now, what if we want to use SQL? So we've been working with Spark so far, but what if we want to use SQL? And so you might be wondering how this can be facilitated. And we can do this by the SQL function that we can reference off of our SparkSession, which enables us to run our application by using SQL queries programmatically and return the result to a data frame. So what we have to do is we have to register the data frame into a temporary view. And how we can do that is by a function called create or replace temp view. So let's go ahead and do that. We can write create or replace temp view, and over here we will name the table that will be referenced in our SQL code. So we can write analysis data, for example. I'm just going to copy this so we can use it later on. So when you run this, what this is actually doing is it builds a Hive table abstraction on the data frame that we're using, so we can run SQL syntax on it. So how we can do this is then we can write Spark SQL. Let's write, for example, select customer ID, total charges, monthly. Yeah, we can write monthly charges from analysis data, where the total charges, let's add a condition here, are greater than 5,000, for example. And then we can write show. So now we're selecting the customer ID, total charges, as well as monthly charges from the table that we created an abstraction in Hive for. We reference that table in our SQL code, and now we've outputted it. So now we can do this actually, even though this is a lot easier to do this in SQL. What if we wanted to, duplicate the exact same result, but use Spark code instead? And this is a nice segue to the next filter we'll be using, which is called filter. So what we can do is we can write df select, because we want to select these 3 columns, and we have to put it in brackets because we're selecting more than one. So we can write customer ID, total charges, monthly charges, and since we've selected that now, we can do filter df total charges greater than 5,000, show first 5 rows. And as you can see, this duplicates the exact same result we got from our SQL code. Now, another way we can write this is by using an alias for filter called where. So let me just show you how that looks like right here. We can take this last part away and write where. And you can actually do the filter all in one step within the quotation marks. So write show. And as you can see, all of these results are the exact same. So this is just an interesting way where you can use where as well as filter. What if you want to use multiple conditions and not only one? What you can do is you have to assign an AND operator. So what that means is, let's say we want to do, first we have to put this in brackets so the function doesn't get confused. And we can write df monthly charges less than or greater than 100, for example. So now you see that the monthly charges are filtered for greater than 100 and the total charges are greater than 5,000, and these are the results that are being gathered from this particular line of code. So this is how you do multiple conditions while using filter. So moving forward to the next function, what if we're trying to do an aggregation on a particular group? Let's try to find an example here. DF columns, see the columns that we can group by. Um, let's say we're trying to find the average total charges by the payment method. So what we have to do is we have to pass this thing called the group by and specify the column that we're trying to group by, which is payment method. Then we can specify mean, and what we want to take the average of, or to get the mean of, is the total charges. We can show 5. So what it's showing here is a list of all the payment methods within our dataset and the average total charges for each payment method within our dataset. And now this is a handy tool. It doesn't really, it's not really practical in the cases of, when you're in a real life setting, you're probably not doing an aggregation on one column. So how about we want to get the sum and the mean for the total charges as well as the monthly charges? How can we do that based off of this code? Well, we have to introduce something called an ag method on top of the group by. So first, what we have to do is import the functions that we're going to need so we can perform this method. So we have to go all the way up top here. And let's say we want to get the average, the count, the max, the min. We're only going to be using the max and the min. I'll just show you. I'm just trying to show you what others are available. And if you click tab, you'll be able to see all of the functions that are available within PySpark SQL functions. So this is why I want to show this to you here. So how we can actually do this is we can write df group by payment method, and what this does is by adding a slash here, we can go down in the bottom and it will register from the first line up top. So we won't lose where we are in the code. So we can write, and this is sometimes done, and I do this a lot, it's just so I can get a better like organization and see what I'm doing a lot easier. So let's say ag over here, separate those two. And we can write sum total charges. And we can use the alias function to actually change the name. So we can write sum or sum total charges. And we can write, for example, average total charges, alias average total charges. And then we can take those two here and then copy it for our monthly charges. Awesome. So if we click enter here, it says invalid syntax. Let's see what we did wrong. Oh, we just forgot the column. We just got the comma. Great. So we can show what we did. And as you can see now with the payment method, we have the total sum charges, the average total charges, as well as the sum monthly charges, as well as the we can write average monthly charges here, just so we're consistent to the average monthly charges. So this is a more useful or practical way you would use and how you would combine the group by as well as the ag together, so you can get a table that will look something like this. As it is it's very rare that you would do an aggregation for one particular field unless it's something that is really, really important for the business or something along those lines. But when you're doing analysis, you generally want to have a bigger picture on the data points that you have. So this is how you would use group by. So in a real life setting, you're more likely than not going to work with data frames that are not necessarily clean. And this can lead itself to working with or identifying null values in your data set. And how you deal with these null values can really impact your analysis as well as your machine learning model. A way we can identify these NA values is we can try to isolate them and see what kind of null values we have in our data set. So in this case, what I'm going to be showing you is how to use the drop NA function as well as the subtract function. So let's use the drop NA. So in our data frame, if we write drop NA and then write the argument how and pass any, this will show us all of the it will drop all of the rows that contain at least one null value in our data frame. So if we return this and if we save it, let's label it df dropped, and then we can see what this looks like. All right, great. So we don't really have a general understanding of what we actually dropped. So for us to see what we dropped, we can write df subtract what we actually dropped in our original data set, and we can show what that is. And you'll see here on the right, it dropped all the rows that contain the total charges of null. So this subtract function that we use here, what it does is it matches all the rows that we had in our data set, and it takes it away from the full data set. And this way we can see what exact null rows were dropped. So how to deal with this missing data takes a few skills as well as some business context and understanding. There are cases, and even though not many, where you can drop those NA values. And in other ways, it could be done by taking the mean of the column as another way to work with this issue. Another way we can do it is by using machine learning, such as using KNNs or using a SMO, synthetic minority oversampling technique. I won't be getting into that right now, but I just wanted to give you an understanding of what we could do with this drop NA. What we could also specify in the drop NA is something called thresh. So if we write df, actually let's just use it separate. If we write df drop NA thresh 2, what this will do is it will, when you specify the number here, you will drop the null rows that contain at least the number you specify in the thresh value. So if you write, for example, 2 here, there will have to be at least 2 rows where there's a null value for the data frame to, or for the code to drop those particular rows in our data frame. This will wrap up our tutorial. In this video, we covered some fundamentals of big data and what Spark is. We then connected our Databricks account with our AWS account and deployed clusters for our Spark application to run on top of. Then I showed you some functions that are particularly useful when getting started with writing Spark code. If you enjoyed the video, please feel free to hit the like button. Thank you all for your time, and I'll see you in the next one.